Hi everyone, welcome to my channel. Today I'm going to discuss the topic for Automation 1, IEC and ISA instrument symbols. So this topic is for week 14. So it says here in your topic, in your learning objectives, identify various instrument symbols using International Electrotechnic Commission, which is IEC. And International System Automation, ISA or ISA. So in here, your table of competence is taken from the STCW function. So just read this table of competence so that we can proceed. So International Electrotechnic Commission, IEC, and International System Automation, ISA or ISA. Identify the various instrument symbols using International Electrotechnic Commission, IEC, and International System Automation, ISA or ISA. So after this discussion, I will give you, we have also here the another topic, discuss the IEC documents addressing policies and procedures versus functional requirements. So after this discussion, I will give you class oral station, and I will give you also quiz 8. So for your lab manual exercises, so exercise number 13. So I already uploaded your form in your LMS, which is the Binacle. So just download it and have it printed. Then you have to do your exercise in handwritten. So after the completion, you have to upload your exercise in your LMS, in your Binacle. So let us continue. So here, we have the International Electrotechnical Commission, which is IEC. So it's the world's leading organization that prepares and publishes international standards for all electrical, electronic, and related technologies. So close to 20,000 experts from the industry, commerce, government, test and research labs, academia, and consumer groups participate in IEC standard decision work. So next we have ISA or ISA, the International Society of Automation is a non-profit professional association founded in 1945 to create a better world through automation. ISA or ISA advances technical competence by connecting the automation community to achieve operational excellence. The organization develops widely used global standards, certifies industries, professionals, provides education and training, publishes books and techniques articles, hosts conferences and exhibits and provides networking and career development programs for its 40,000 members and 400,000 customers around the world. So we have here uh, the different symbols that were used in the electricals, electronics, and different system in automation. So instead of uh, reading this one by one, I had to just show the slides, and then later on I will show you the examples, the application of these all symbols. Just familiarize all these uh, symbols. So these are symbols used in automation. So I just show you these slides, but later on I will explain the applications using of these all symbols. So a lot of symbols here uh, in this topic. So these symbols are used in engineering. So for the ESA, uh, symbols This is around 50 slides. So a lot of symbols here used in the automation. So we have here an example of the diagrams. Examples of diagrams. So we have here also the IEC, International Electrotechnical Commission. So remember, the symbols, the electronic and electrical symbols uh, in the IEC are applied to electronic and electrical symbols, most of them. But the symbols, the application of the symbols in uh, the ESA or ISE are mostly applied in the engineering uh, diagrams, automation diagrams. So this IAC and uh, ISE are used together with the automation system. So later on, you can see the example of the application, but I have to continue with all the symbols. So let us come with the IAC or International Electrotechnical Symbol Commission uh, symbols. So these are for electronics and electrical. So just uh, play all the slide first before we come to the application. So these are the electronic symbols that is belongs to the IEC. IEC symbols, manual button normally close, maintain, manual button normally close, spring return, manual button normally open, maintain, and manual button normally open, spring return. So these are push buttons. We have also pilot lights. So this is pilot light. pilot light transformer type, pilot light transformer type from B, pilot light blink, pilot light transformer, and this is pilot light. So these are all pilot lights. We have also here the normally open single circuit, main tare push button switch, form a switch contact. So stack symbols to form multi-pole switches, combine with symbols 5, 5, or 6 to form toggle or rotary actuator switches. So we have it also, so as you can distinguish here, the normally closed and normally open and normally closed contact. You can see the different. So normally closed single circuit, momentary push button switch. So form this switch contact. Stack symbols to form multi-pole switches. Combine with symbols to 5 or 6 to form toggle or rotary actuated switches. So we have also here the normally closed, normally open double circuit. Momentary push button switch. Form C switch contact. Stack symbols to form multi-pole switches. Combine with uh, symbols 5 or 6 to form toggle or rotary actuated switches. So we are here in the application using uh, the diagram and the different symbols used in the IEC or ESA. So we have here the FIC, which is flow indicating controller that performs a square root flow calculation primary location. So we have also here the TIC, temperature indicating controller field mounted. We have also here the TY, temperature computer, and FT, flow transmitter. We have also here the uh, pneumatically actuated valve, and we have here the pneumatic line, the symbol, and this symbol uh, YIC is the PLC or programmable logical controller that controls all the uh, circuit or the components within the system. We have also here TT, which is temperature transmitter. So we have also here electrically actuated valve. So in here, the output of FIC 101 is an electrical signal to TY 101 located in an inaccessible or behind the panel board location. So these are all the description. So this one, FIC 101, square root extraction of the input signal is part of FIC 101's functionality. Here also FT101. FT101 is a field-mounted flow transmitter connected via electrical signals. So dotted line to flow indicating controller FIC101 located in a shared controlled uh, control display device. We have also here the output TY101. The output signal from TY101 is a pneumatic signal line with double forward slash marks, making TY101 an IP current or current to pneumatic transducer. So that is IP or electronic pneumatic IP. Here we have the FIC101 here. So here this is a square root. Here FIC101 101's output is connected via an internal software or data link. Line with bubbles. So the set point is P. So here. So of FIC 101 to form a cascade control strategy. So the TT101 here and TIC101 here are similar to FT101 and FIC101 but are measuring, indicating, and controlling temperature. So this one here is the air supply. So here I have to explain. So I'm not using my camera now to have a full view of this diagram. So this is a complex examples combination. So here example of a complex batch kettle control involving both shared display control and programmable logic control, which is PLC. So PLC is a lot of application on board ship PLC. So the purpose of this drawing is to allow a general understanding of the control scheme and to define and identify the connection components. So detailed understanding would be obtained from the study of the other documents. So here, as you can see, TY. So I found uh, this diagram on the other uh, documents, which is, belongs also to ISA. So I put in here to easily visualize the system. So here, TY, where is your TY? So TY meaning temperature computer. This one, this symbol. Here, if I say is flow indicating controller that performs a square root flow calculation, primary location. So this one. And here is TIC temperature indicating controller field mounted. So that is TIC. We have also here the FT. FT is a flow transmitter. This one. And we have also the YIC. So your YIC is the PLC or programmable logic controller. So PLC is the control of all components within the system. We have also here the so I think I already mentioned all here. So YIC I already mentioned. This is the PLC. So this is a YIC or these are YIC. This also this one. So that is how to identify uh, the symbols on the diagrams. So applying with the symbols taken from the ISA or ISE. So let us proceed here. So we have also here the instrument line symbols. So let us come with a line. So I forgot to mention also this one. So the SP is a set point. Set point. So here, let us come with the line. So as you can see here, this line is a internal system link. So software or data link. So this line. And this line, this is a so I think it's not given here. So you can find in the other system. But similar to this electric binary signal, electric signal. So this is electric signal. This one. This is electric signal. So I already here I already explained in the previous slide. So these are electric signal, electric binary signal. This one and this one is uh, electric signal. This one because this actuator. So this one also here, this part is a current transformer measuring current of electric motor. This part. So let us come with the actuator symbols. So your actuator symbols are this one, as you can see here. This is cylinder. So actuator symbols. So 1, 2, 3, 4, 5. So you have 5 actuators here. So actuators, as you can see here, these symbols. So prepared for any cylinder that is measured with a pilot, so that assembly is activated one by one control input. So we have also here diaphragm type. So a lot of actuator. So in here I see this is piston actuator. Piston cylinder actuator. So that is the application of the different symbols to the diagram used in the automation in engineering. So just review all these symbols for more understanding. So in your lab manual exercise just simple. You just follow this instruction here. So this form I already uploaded to the LMS, which is the Binacle, and all you have to do is to download the form and have it printed. Then you have to do your exercise in a handwritten, because supposedly your exercise you have to do in a lab manual, which is handwritten. But since our system now is we do the paperless submission to your LMS, so you have to just uh, take a photo or a clear image, and then you have to paste in the uh, Microsoft Words, then convert it to PDF, then submit it back to the Binacle, in PDF format. So you have to upload in Binacle in PDF format. So for your lab manual exercise. So this is the end of our discussion. Hope you learned something with the symbols taken from ESA and IEC. So when you are on board the ship, you are reading the diagram. So at least you have uh, the brief idea, the basic. So important is the basic. So further understanding is you have to study uh, a lot, study more. So thank you for watching. Please click like and share and uh, write a comment below. And then please hit the subscribe button and the bell icon. Thank you for watching and see you on my next video discussion.